that we talked about input modalities, we have different type of output modalities that deal with our different senses. The most common ones that we have are naturally the visual displays that we are all using right now. Basically, the 2D images that are used as the output. Again, this can be a couple of different ways. For example, raster graphics, or as we see later, non-raster vector graphics, and a whole bunch of other things. Even printers and oscilloscope and things like that can somehow be considered visual display. But visual displays are not the only way of providing output to the user. As you, for example, know, another way of providing output is a haptic interfaces or haptic output. Haptic basically means something that has to do with our sense of touch. If you have played console games, you probably noticed when your controller vibrates. That's some sort of very, very simple force feedback or haptic feedback. There are more complex systems that use basically our sense of touch and provide output to us. Audio is another very common way of providing output, the systems that actually talk to you or generate different type of sound. Text-to-speech systems are basically created as part of this whole process. So you have a text that's supposed to come up on screen, but instead you have a technology that reads text and automatically generates a speech based on that. Some other output modalities that are not used very often, or really not commercially, are smell and taste. You can imagine that creating outputs that are based on smell and taste can be quite difficult. But actually there's been research working on them too. And they're not, at least theoretically, that different from visual display. When you are creating visual displays, you are basically creating different pixels, each one of them defined by 3 components, red, green, and blue. There's research on what are the components of different tastes or different smells, and allowing a system to combine them and create an output. But for obvious reasons, they are not commercially successful yet. So, I mean, you don't want your computer to smell or taste or something like that because it can be awful. But there's been research on that, and I'm pretty sure that at some point we will have something related to that. So, and finally, what do we mean by a multimodal input-output system or multimodal human-computer interaction? The idea basically is that we have all of these different modalities, and in reality, in physical world, we're not limited to just one. We use all of them. Why not for a computer-based system use all of them, or at least more than one of them? So you'll get to systems that are trying to use more and more of these modalities as input or output level. To let people feel more natural, to let them basically receive information faster and more conveniently. So again, moving forward, just as a couple of examples of what are these possible modalities and these technologies, I have some suggested case studies for you guys if you want to go and even like analyze them yourself and get to go back to the history of them. For example, GUIs, graphic user interfaces, which we will get to very soon, are basically a case of user interaction. GUI as a technology has gone through a whole bunch of different phases and many different results, and it'll be interesting to go and see how it started and what changes we've made to it, and where we are now. For example, from simple 2D interfaces all the way to more complex things. I'll get to that. Or web is another case study. What are different ways of interacting over web? And obviously computer games. So I'll try to talk about some of these things and introduce some of the technologies that we have used for these cases or other ones. For example, here you see some examples of some of the interactive technologies when they started. You can see that most of them started in universities as research. Then we basically went to this phase of commercial research or corporate research, and eventually we got to being commercially used. It's interesting that most of them started way back, even in the 60s. People started doing research on, for example, the speech processing and things like that. But many of them are not yet commercially successful. I'll get to some of these examples. For example, vision-based systems. We still have problems with systems that are using vision, computer vision, as a way of providing input, although there's been decades of research on it. So as these examples that I said, to start with, let's talk about graphical user interface. So the initial computer systems that were designed as pure text-based, probably around early 70s in Xerox Alto Computer Research Center, the first graphic user interface was created. And the major components of GUIs haven't really changed much since that time. And these basic elements are things like windows and icons and buttons and having a mouse and to click on them and things like this. See, these basically define the basics of a graphical user interface, at least the way that we know it. You can imagine that these days we have at least research on coming up with new types of GUIs. For example, just as kind of a brain teaser for you guys to think about, three-dimensional GUIs. So right now we have this concept of a desktop on our computer. So you see menus, you have icons, you have buttons, you click on them and things like that. What if we move one step ahead and we talk about real desktop? So have a computer that shows your environment not as a 2D desktop, but as actual 3D desktop. So you have 3D objects on your screen, and you can interact with your objects as 3D. So your folders are really like, for example, drawers in your room or things like that. So there's a lot to talk about when we get to things like this in terms of what exactly we mean by 2D and 3D GUIs. And I don't really want to get into detail of it. The other system that I wanted to mention as